Hey everyone, let me ask you a question. How many WhatsApp messages do you think in a single day we send? Answer is 100 billion. So 100 billion messages are not small. Sometimes it is more bigger than that. Okay. So these 100 billion messages includes general messages, video messages, group chats, documents, files, images, everything. So we are interested to know how this design works. I guess you are yes. So in this video, we are doing a complete system design of WhatsApp from scratch. I'm going to show you how a message travels from the moment you press send through the multiple servers, databases, queues, and all the way to your friend's phone in just 200 milliseconds below. This is not just a theory. We are going to look at the actual technology. WhatsApp uses a LANG of chat services, Apache Kafka for messaging queue, Cassandra for storage, CloudFront for video deliveries, and whether you are a beginner or a senior engineer preparing for a system design interviews, this video have something for you. Stay tuned. Hey everyone. This is the most important concept of this WhatsApp design. Why? Because I will be explaining this system design about how a message, when you send it from your mobile, how it reaches to your friend's mobile, every component, how it flows the message from your side to your friend's side, I will be explaining. At the same time, when it is sending via your phone to reaches to your friend's phone, what all components when it is involved and what is the technologies used in that to process that messages, I will be explaining in the system design. Okay, so if you feel that these components are known, just skip the make the video a little bit faster. If you don't know, means just listen it concentrately, so that hopefully you will learn something from this video. Okay, so let's start. Okay, so first, as I shown you, this client A is the person, your phone. Okay, it's think that it's your phone and it's a Android phone. Okay, you are sending a message from your phone. What happens? So whenever you are sending a message from your phone, a WebSocket gets opened from your phone to the WhatsApp servers. Okay, so what is this web server? Earlier in my starting of this video, I have explained what is web server. So WebSockets. So WebSockets is a communication protocol, I can say it as, that provides a persistence full duplex two-way connection between sender and the receiver. So at that time also I said that how it is different from the HTTP request. Okay, so with regular HTTP request, the client always initiates a send request, gets a response, connection closes, it like it continues for every message. But in the WebSocket, it's totally different. What happens is, whenever a WebSocket opens, right, without any acknowledgement of sending a message or receiving a response, a direct connection gets established between you and the receiver, and the connection will be there till the message session ends. Okay, so all the messages will be flowing from your phone to the other end and receiving from other end to you. Okay, so that is the benefit of WebSocket, which is very lightweighted, and it carries a set of kilobytes of memory in it also. Okay, so now when a client, when your phone, when you send a message, right, this WebSocket gets opened for your friends connectivity. Okay, for your friends WhatsApp chat. Okay, so when a request, you send a message, right, it immediately goes to the load balancer. Okay, so if you see, I'm just stopping the play button every time to show you the flow slowly. Okay, so now your request reaches to the load balancer. You can see the request is reached to the load balancer. So the load balancer, what it does is, it collects the request from the client, and it calculates some kind of calculations. Okay, load balancer will it will be having multiple load balancer in the production server. So this will try to segregate your request to a specific server. Okay, so that every request from your end will reach to that server. Okay, so how this calculates? So before to calculation, I will go one step forward. That is, from load balancer, it will goes to a chat server. You can see the chat server. What is the chat servers? Okay, so these chat servers are a physical servers which are available in the general cluster environment. Okay, what this does is, it acts as an receiver and deliver layer. Okay, something like it takes a message from you and sends it to your receiver, okay, your friend. Okay, that is the process it does. Okay, and one more thing before to it, right? What it happens is, whenever you're sending a message, right, your user ID will be calculated with a hashing technology mechanism. Not only on the user ID, specific parameters are there. I don't want to go deeper onto that, but a hashing logic will be applied on top of the user, and a number will be derived. Okay, in the production, right, you can see here that there is 1 to n. Okay, but in production there will be hundreds of chat servers. So when your ID is received with an hashing number, right, for that specific hashing number a chat server will be assigned. So all the messages from you will be reaching to this chat server, any one number. Okay, so suppose think that you are user 1, okay, and you have an hashing logic added to this. Okay, so you got a value called as 2. So think that you got a value as 2. So now your every message will be reaching to the server 2. Okay, so any message you're sending to your receiver client B, those all messages will be every time reaching to the server B, server 2 only. Okay, chat server 2 only. So any message receiving from the client B also will come to the chat server 2 and it will reach to you. Okay, so that I will come back. Okay, so now chat server 2. Okay, so next what it happens is, when I click play button, okay, so now the chat server will connect with the messaging queue. You can see the green line flows to the chat server and the green line flows to the messaging queue also. Okay, so this messaging queue is nothing but a Kafka queue. Okay, what is this Kafka queue? It is an in generally Kafka is a general term, everybody knows it, but those who don't know, I will explain you what is Kafka. Okay, Kafka is a distributed messaging system used to handle huge volume of real-time data between the producer and the receiver. Okay, so what it does is, the producer sends the huge amount of messages without understanding the receiver how it's taking. Okay, he just pushes the messages, and the Kafka is the middle line queue messaging system where it takes the messages to the queue, and the receiver, when he register the topic, he will receive the messages from the Kafka which producer has sent. That is the way it happens. Okay, so now the messages flows from the chat server to the messaging queue. Okay, so one thing I missed it. So what is the technology used to send these messages from the client A to chat server and then from chat server to messaging queue? That is called Erlang. Okay, note it, ERLANG, Erlang. This is called an lightweight, what in technical wording, what we say is that Erlang is a general purpose concurrent functional programming language. Okay, which is originally developed in Ericsson in 1980s. Okay, and it was built as fault tolerance distributed telecom system. So it is specifically for the telecom system, networking system. This Erlang is a very lightweighted. It can carry a some kilobytes of data within the every request. Okay, Erlang. So WhatsApp messages also, every message will be some bytes. Okay, so Erlang processes it, these messages it carries in itself with every request and sends it to the chat server. Okay, so that is the way it flows. Okay, so that is the thing I mentioned here. Erlang OTP is nothing but the Open Telecom Protocol. Okay, telecom protocol. Okay, so using Erlang, whenever the WebSocket opens from the client, right, Erlang programming, using the Erlang programming, it carries the messages from the client to the chat server. Okay, client server. Then the chat server will post the message to the Kafka topic. Okay, so you can see a green line is going to the messaging queue, and there is another blue line flowing to the connection register. What is this? So this is nothing but, so what I can say it as, if you see, a green line is flown to this messaging queue. Okay, there is another blue line. Okay, there is a blue line, it is flowing to the messaging queue. What is this blue line? Okay, so let me go 1 minute. So what is this blue line? Okay, this blue line. Okay, this blue line, this is nothing but a registry. Okay, nothing but it's a registry. What this registry does is, whenever a chat server is sending the message to the message queue, there should be someone to receive. Okay, so the message will not be directly posted to the client B. Okay, so it will be posted to the Kafka, and from Kafka there should be someone to pick the message and send it to the receiver. Okay, so when it is sending the receiver, right, the person who picks that messages from the Kafka, he should know where to deliver. Okay, and when there is a message coming from the receiver, he should know that where this message should deliver. Okay, So in our case, client A is sending the message to the client B. So the client B, when sends the message, how the client B will know where the client A resists and how this message will flow. So what this registry does is, the connection registry, it registers the each client and the chat server. So client A, so it is like something like client C1 register to chat server CH server 2, okay, like this it registers, okay. So whenever the client 2 sends the message, right, return to the client 1, so it will check whether the client 2, what is the chat server assigned to it, okay. So it will get the server 2, okay. Then the client 2 will send the messages which comes from the client 2 will reach to the server chat server 2. The chat server will send the message to the client 1. I will come to that, okay, later, okay. So let's now again come to this one. So the chat server will connect to the connection registry. So connection registry will have the details like client A has sent a message which is been sent via the chat server 1, and so this is the communication link, WebSocket link established between the client A and the chat server 2, okay, we can say it as. So now the messages are pushed to the Kafka topic. Before to that, right, one thing I missed it here, sorry to remind it. So before the message is pushed, right, every message will have a unique ID, okay. What is this unique ID? So this is a unique ID will be used by the messaging, let me cut it, what is it that is. So the chat server, before putting the message to the Kafka topic, right, it connects to the IDs generator, okay. What is this ID generator? It's a snowflakes technology where it generates a 12-bit sequential ID for every message on the timestamp, okay. So whenever the chat server, before pushing the message to the Kafka topic, it connects to the chat server ID generator, okay, and the ID generator will generate a unique 12-bit of sequential ID and assigns that ID to the message, and that message is posted to the messaging queue, okay. So how this will be helpful is, whenever think that the client B is offline, okay, client A is sending 10 to 20 messages. So all the messages having some time frame gap, okay. And when these messages, when the client B comes online, the order of the messages should be posted to the client B in the same order, okay. So this ID with the timestamp helps the client B while pushing to the client B chat box in an order, okay, sorting order it will come. So that way it is a plus point for the ID generation, okay. Now now we have the connection registered, okay. So now next what happens? So you can see MQ, okay, you can see the messaging queue. So messaging consumer MQ, that is called message queue consumer. So it is connecting to the it is connecting to the message queue, okay. If you see, it is pulling the messages from the message queue, okay, that is from Kafka. It is pulling the messages. At the same time, this MQ is connecting to the connection registry also, okay. So if you see what it does, why the MQ consumer is connecting to the connection register, okay, what is the purpose is, so the messaging queue consumer plays a middle role to store the messages consumed from the Kafka topic to a storage place. Why? The reason is, supposing that you are sending the message to client B. Client B is offline, okay. So now how the messages will be delivered to the client B? So the messages cannot be kept in the message queue in the Kafka topic for a long time. Kafka topic has a default 7-day of storage, and we can extend that one. But more than that, right, it is a burden for the Kafka topic to carry the messages, okay, because there are billions of users who are posting it. Suppose one user lost his phone, he is not able to purchase the phone, or he is not able to activate the WhatsApp within 1 week, okay, and the messages are been queued in the topic. So it's a bigger kind of queuing system happens, and there will be a chances of, if there is some disturbances or something happens, the topic can lose the data based on the terms and policies of the Kafka topic, okay. So instead of storing the data messages in the queue in the topic, what we'll do is, message MQ consumer will pull the messages from the messaging queue, will post the messages to the cache inbox. What is this cache? This is a Redis jet set in the sense sorted set, okay. So whatever the messages comes in the order of the client A, the same way it will put it into the sorted set, okay. So that is the Redis set, okay. So like that, if we post the messages in the inbox, and at the same time, the same messages will be stored in the Cassandra. Cassandra is a distributed framework where the messages will be stored in a distributed environment. So there is no chance of fault tolerance, okay, a goodly handled fault tolerance. Any chances of losing the catch inbox, the messages will be available in the message DB, that is Cassandra, okay. Now, at the same time, I missed to say that the connection registry is also managed by the Redis, okay. So every client A with the server is registered there. Now think that the client B is still offline. So the work of the MQ consumer is to send a notification to the client B at the same time, saying that this client B is offline, and ask him to come online. That's a simple message. It's not something like the client A is sending message, you are offline. That's not. When you are offline, network is not available at the time, right? There will be a banner showing in the top as a notification like you are offline, okay. That is the notification it shows here, okay. At the same time, this is general notification. It's not a notification from the messages from the client A, okay. And at the same time, this message MQ consumer doesn't know that client A it will check for the client B is registered with the chat server or not, okay. If it is not registered, it will consider the chat client B is offline, and it stores that message to the message DB, okay. Okay, this is the way it flows. So now supposing that the client B comes online. So let me play the button, what it happens. So you can see the orange line flowing back to the chat server. So what it happens? So the client B came online, okay. Immediately what it happens, the client B opens a WebSocket, okay, and the same flow how client A's WebSocket is opened, right? The same way the client B also opens a WebSocket which connects to the chat server. A connection will be established via the Erlang, and chat server will understand that there is a client B came up, okay, and it will try to see whether any messages coming from the client B or not, it will see, okay. So at the same time, it will see the client B is having a messages or not. At the same time, it will check the chat server will connect to, you can see a line in the chat server connecting to the catch inbox here, okay. So why it is connecting to the chat server? Chat server is connecting to the catch inbox. It checks whether any pending messages from the client A wants to reach to the client B is available in the catch inbox or not, it will check. Why? Because already the client A is sending some messages, right? It will have the details about the receiver, okay. So that way it will check in the catch inbox whether the receiver client B is the client B and he is having any pending messages in the cache or not, it will see. If it is there, means it will take all the messages and start sending it to the client B via this top arrow, okay. So let me play it how it goes. You can see it is playing from the top arrow, okay. So this way the client server will pull all the messages from the catch server messaging DB and sends the messages to the client B. At the same time, the client B also gets registered in the connection registry by the chat server, whatever the chat server sent to the client B, okay. So why so? So now whenever the client B is sending, now the client B is online and the client A is online. So now the process again flows. When the client B sends a message, it reaches to the chat server, it connects to the messaging queue, it puts the message, and then it registers the client A chat server with the connection registry. MQ consumer will read the message from the messaging queue, checks the client B receiver, that is client A, from the connection registry, checks who is the respected chat server for the client B or for the client A, sorry, and it sends the MQ consumer will send the message to the chat server. Mark my words, MQ consumer will send the message to the chat server. Chat server will send the message to the client A, okay. This way the total flow happens and there will be a 2 blue ticks comes to the client A when the client B sees the message or the client B reads the message and sends a message also to the client A. At the same time, both will get the 2 blue ticks, okay. So this is the way total system cycle happens when a message is sent from the client A to the client B, and reverse when the client B sends the message to the client A. And if the client B is offline, how the MQ's consumer will read the message and post the message to the catch inbox, and the message will be stored into Cassandra for the data. What is that? I can see it as not to lose the data. And when he comes online, the client B will have a WebSocket open, the chat server will pick the message and post the message to the client B, okay. That is a full cycle, okay. Hope this you are clear. If you are not clear, post a message on the comment. I will reply on that. Now let's see how the video message is sent from a sender, that is client A, to the receiver, client B. Okay, so video message doesn't react as the same way as like the text message sent, what I have explained in the previous architecture of the text message. So video message is bigger in size format. It is different in the resolution, and many other parameters are there with the video message. For example, for a text message, it hardly takes some kilobytes of memory, but video message starts from 1 MB minimum and ends with unlimited. Okay, but we have WhatsApp limited with 120 MB to be sent as of current date. Okay, if you send bigger size, it will try to split that video into smaller part, which can fit to that to a bandwidth to send the MB, that is 120 MB. Okay, so what happens when you upload a video to your friend mobile, okay, to his friend chat? So whenever you are uploading a mobile video, immediately what your mobile does is it has a compressor built up in all mobiles, as I said earlier in the starting of my video. So every mobile have an hardware called H264 and H265 encoder. What it does is it compresses your video size into smaller size with a better quality. Okay, so supposing that you are uploading a 100 MB video, it is compresses into 5 MB, which is 100 times smaller, 100 times smaller than the video which you are actual size. Okay, so immediately your application, that is WhatsApp application, calls a media service API to the precise S3 URL using a precise S3 URL with a cryptographical signed URL that authorizes a direct put request to the Amazon S3. Okay, so what is this? So why I use the cryptographical signed URL and an authorized? Whenever a user tries to send a video, right, it should be encrypted in a format that nobody can decrypt it. Okay, it creates a layer of security with the S3 while uploading it to the S3, and once you upload, right, a URL is generated. Okay, so the URL here I'm saying is the connectivity for the S3. Okay, so a put request will be created to the S3 and the video is directly uploaded to the S3. So while uploading, right, the connection uses the TUS protocol. Okay, listen my words, that is TUS protocol. What is this TUS protocol? It's a protocol which helps the user to not to drop the video when it is uploading. Okay, in a better way, how can I say is, supposing that you are uploading a video to your friend's chat, some internet issue came up and your video is stopped at the middle. Okay, so when the internet is back to the normal position, right, when you hit the retry, you would have seen the place where it stopped, right, it starts uploading from that, it will be showing like 60% and it starts 61%, like that upload starts. Okay, so this happens via the TUS, okay, protocol. Okay, so now what it happens, so if you see my the architecture, what I'm showing here is the client is sending to the object storage. Okay, so a direct line is going to the object storage from where the client have uploaded his video. Okay, so next we will go to the next position is client, the video is uploaded. So from here, right, there will be an automated process triggered from the S3 to the processing queue, that is an request, an event kind of request sends from the S3 to the Kafka processing queue, which will have the details like the video URL, okay, the video ID, and the client details. These all basic details will be there, which will be sent as an event to the Kafka topic. Okay, that is which you can say it as processing queue. Okay, what this Kafka topic does is, this message with the details will be forwarded to the transcoder. Okay, so transcoder, if you see here, I mean, this is the place where it comes. Okay, transcoder. So what this transcoder does generally? Okay, so transcoder will have a components called FFmpeg and CUDA. Okay, repeat my wording as FFmpeg and CUDA. Okay, what this component does? So whenever the event reaches to the transcoder, right, transcoder uses these components called FFmpeg to generate multiple resolutions. Okay, on top of the same video. Okay, so this Kafka is sending the event of the S3 video URL. That video URL will be there. So with that URL, it tries to generate that same resolution. Suppose you sent a 720 pixel resolution. With that resolution, it tries to generate multiple formats like 1080 format, 480 pixel format, 360 pixel format. Like this, multiple pixel formats it generates, and every every video will be again stored back to the S3, and every video resolution will have its own URL. Okay, so these all 4 resolutions will be sent back to the S3 via transcoder. Okay, by the transcoder. Okay, so now bit knowledge about I want to share with you about what FFmpeg does and what CUDA does. Okay, so as I said, FFmpeg does the heavy lifting. Okay, it's an heavy lifting engine. What it does, it's an open source multimedia processing framework. It can decode, encode, transcode, etc. It does it and plays almost any media format. Formatted video it sends. Okay, so it creates the formatted video which is fit for any kind of mobile operating system. Okay, OS system. So earlier we were having now we are having two OS only. Okay, in China different type of OS, but China is not using WhatsApp. That is different story. Let's stick to the point of the video. So currently if you see, there are different video formats like the video formats we are having. At the same time, why it is required is different mobile uses different OS. Okay, our Android OS, iOS, okay, like that earlier there was a BlackBerry OS. Okay, and UI itself is having their own OS. Okay, so like that different OS will be there. So for that OS, right, this video format should fit. Okay, so FFmpeg does that kind of resolution, that kind of formatting video, it does it. Okay, and what that CUDA is an compute unified device architecture, is a parallel computing platform in simple, if I'll say, where the programming model created by the NVIDIA. This is a platform which is created by NVIDIA, which runs on GPUs. Okay, so FFmpeg uses this CUDA GPU machines to generate these kind of resolution videos, different kind of resolution videos. Okay, so if CUDA is not there in place, what happens? Then FFmpeg will use the CPU machines in the servers of the WhatsApp, where it will try to, with the CPUs, right, it will be very slow and too much of traffic will be there, and due to that, right, more clusters will be used to generate the video, and there will be many things happens with the CPU when it goes. Okay, so instead of giving the faster delivery for the video which is sent, GPU is the best alternate than the CPU. Okay, so CUDA is the where it gives the GPU flexibility to generate different type of resolution videos. Okay, so that is the way the transcoder uses these two components, FFmpeg and CUDA, to generate different resolution videos. Okay, but now these resolution videos are stored back to the S3, and these all details having the meta information like URLs, video IDs, and resolution IDs, everything. Okay, so those all transcoder will forward it to the CDN. Okay, CDN, that is the content delivery network. Okay, this is a common word been used by many bigger kind of streaming applications, many different kind of any kind of different kind of bigger architectures. Okay, is used CDN. Okay, that is content delivery network. Okay, related to the streaming network or what I say, any kind of video formats or audio formats you send, right? The CDN will help us to deliver the content. So content delivery network. Okay, so simple in the word is content delivered network. The word itself says everything. Okay, so this for this metadata information reach to CDN. Okay, but here the CDN is a general word, but and we here in WhatsApp, right, it is used as an CloudFront. Okay, CloudFront is an it's an Amazon framework which is built on top of the CDN. Okay, and it is used to distribute the content into globally in all edge nodes. Okay, so in simple, if I say, when the metadata reaches to this CDN, right, the CloudFront, that is Amazon CloudFront, catches these details and sends this information to throughout the globe edge nodes of the AWS servers. Okay, so now in simple, if I'll say, in a small way, I will say, in an easier method, you are in Mumbai or you are in India and you are uploading your video. It is stored into Hyderabad location or in Mumbai location servers. Okay, think that. So now this information need to be stored again to this content need to be stored again to the different servers throughout the globe. Okay, so this CDN helps to transfer this information into different zones of different servers throughout the globe. Okay, so the CloudFront plays one of this role, and at the same time it catches this meta information in front. Okay, so it plays a role like between the S3 and the receiver. It plays a middle layer where this information will be cached. Okay, and this is a cache information. Okay, this will be traveled to all the wherever the servers of S3 is there, right? This information will be stored all the places throughout the globe in all servers before to the S3 physical servers. Okay, so this is the component of the CloudFront. Okay, what it does. Okay, so now what happens? So now the information is stored in all the edge nodes, and the metadata information is stored in the CloudFront. Okay, so one information I missed here: the transcoder, when it sends this meta information, right, it also connects to the thumbnail. Okay, thumbnail as well. So let me show you what it happens. Okay, here it is. Okay, what it happens is, so the flow, again, you see the transcoder sends the information to the thumbnail SVC, and at the same time it sends the CDN. Okay, so what this thumbnail SVC does is, it creates a high quality image using WebP. Okay, so WebP is nothing but it takes a frame of the video and generates a high resolution content image for the video, and that image will be stored back to the S3, and that image URL also be attached to this information when the transcoder is sending the meta information to CDN. Okay, so all these meta information, what is the meta information? Like video URLs, video size, video thumbnail, and the this all information. Okay, and this all information will be sent to the CDN, and CDN CloudFront catches this information and stores this information, one of the information, to the Cassandra. Okay, so Cassandra is what is Cassandra does? Cassandra is a NoSQL database where any kind of NoSQL data information can be stored. Okay, so apart from the SQL database, Cassandra is an distributed server, parallelly processing server, high available database where it can store the NoSQL formatted data. Okay, any kind of log information, any kind of JSON information, any kind of the format, that data which doesn't have a format, those informations will be stored in the Cassandra. Okay, in simple. So this video metadata information will be stored into the Cassandra. Okay, so now we have the details that video stored, video URLs, these all things are there. So now this information need to be reached to the receiver. How it happens? So coming one step back. So when this information is reached to the CDN, right, transcoder does one more thing. What it does is, this information will be sent back to the client A. Okay, so what all information will be sent to the client A? The information related to the S3 location where the video is stored with all 4 resolutions, all the resolutions. At the same time, the thumbnail where it is stored, the URL, and the video duration. What is the video duration? The file size, and this all information as a JSON object, it reaches to the client A via the transporter. Okay, and client A sends this JSON message to client B as same as the text message architecture. Okay, so how earlier I explained in the previous architecture how the message is sent to the one from a sender to the receiver via a general flow, the same flow for the video meta information also will be sent. So let me repeat again what it happens is, so client A sends this JSON message to client B via the load balancer. Okay, first of all, he opens a WebSocket to the chat server. Okay, then your request is going to the load balancer. The load balancer interacts with the chat server, and a WebSocket will be opened, and the message will be posted to the chat server. The chat server posts the message to the messaging queue, that is a Kafka, and from the Kafka, MQ consumer will be picking up. Okay, this consumer will be checking to the registry, and the registry where the registry details will have the details about the receiver who is registered to which client server, chat server. Okay, and once those details has been pulled out from the registry, MQ consumer will connect to the chat server, and chat server have already established a WebSocket with the client B. So the message which details is there, right? That details will be again posted back to the via the WebSocket to the client B. Okay, if you see the flow, how it happens, that is the way the flow happens. Okay, so now the message is reached to the client B. So now the client B didn't see the message. Okay, he have an video message came to his chat. What happens immediately when the message reaches to the client B? Okay, the client B app, WhatsApp app, connects to the CDN with this meta information. Okay, it's an auto process. Okay, automated process happens. So what it happens is, the client B connects to the CDN, and immediately the CDN pulls the information related to the meta information, that is what is the video, okay, the video URL, and the client B location, okay, that is very crucial, okay, the client B location where he is located, okay, and what is the video URL, what is the video size, what is the client B network bandwidth, okay, and based on the network bandwidth, right, what kind of OS he is using, and based on the network bandwidth, what resolution his current network bandwidth can support. These all information CDN will collect, the Amazon CloudFront will collect, and will connect to the nearest S3 location server, okay. So he is in India, means it will connect to the Hyderabad or Mumbai server, okay, and will pull the video 2 segments using HLS, okay. What is that? HTTP live streaming video, okay. So 2 segment of video it pulls and stores it into the client B mobile, okay. So that is the 2 segments. What is the 2 segments? Now coming to that person, okay. So HLS segment is nothing but the HTTP live streaming. So if you have seen when the client B starts the button of clicking play, immediately the video starts playing it. So how? Still the video is not downloaded, okay, but it starts playing. So this HLS helps to play that few seconds of video, okay, when it is placed, right, at the same time download also in background runs, okay. So this HLS segment, right, it initially when the video metadata information reaches to the client B, right, at the time itself this HLS pulls the starting 2 segments of the video to the client B and stores that message in his mobile, okay. So now when the client B hits a play button, okay, already the 2 segments is down, already in his mobile is there, so that starts playing at the background itself, right. A connection is established back to the CDN, and what it happens with all information earlier, as I said, right, the client B mobile network details, his OS, everything, okay, will be reached to this CloudFront based on his information of the mobile. The CloudFront starts connecting to the server nearest to him and downloads that video to his mobile, okay. It sends the video to his mobile as a segment using the same HLS segment, as a small segments it will send back from the server to the client B, and the video gets downloaded in background, and it without any, if his network is very good, he will receive the 1080 pixel format, and there itself he will not have any lag in video while he's seeing itself, while at the same time at the background it downloads, because his mobile network is so strong, okay. So like that the video gets downloaded in background, and he's able to watch the video without any streaming, okay, background buffering or any streaming or showing like buffering like to download, okay. Once the video is he started watches, right, at the same time client B sends the deliver request, that is the acknowledgement, to the client A via the same WebSocket which is earlier opened from the B to the chat server back to the message that is the registered queue where the client A details will be there. The client A registry details of the chat server will be picked up, and that will be posted, and the chat server will send a acknowledgement to the client A saying that the video is read, and the 2 blue ticks will be triggered, okay. So this is the way the total video message cycle will run in the background. So you see a video in a one click, but this much of structure is happening in background in the servers, which you will not find a bit of latency also, okay. That is the beauty of this architecture, which is we've been using from decades, okay. We can say it as decades, because WhatsApp is there from somewhere from the 2010 onwards, 8 onwards. Now we are in 2026, okay. So this kind of architecture is being managed, and every time this to make the user more experience perfect, every time the architecture is being upgraded with new technologies, okay. But currently this is the production architecture, this is the technologies being used by WhatsApp in the production, okay. So any new upgrade happens, right, I will be keep posting on it. Hope this video is informative. This specific video message architecture is been understandable to everyone. If you have any doubts, anything, right, please post a comment on to the video comments, okay. I will try to reply on to the message, okay. And hope you learned something with my video. Do subscribe, and thank you.